Good afternoon, everyone. Thanks for coming to this session on machine learning in the browser. Before we get started on this, just want to take an informal survey to understand what the folks in the audience know about machine learning and AI in general. How many people are already familiar with some machine learning stuff? Anybody? Oh, well, that's quite a few people. How many people have done machine learning in the browser so far? Okay, one person. I'm not sure why you're here, but that's okay. You're using TensorFlow for the person that raised their hand? Okay, good. All right. So my name is Pratik Patel. I work at IBM, and I do stuff in the Java space and also with IBM Watson. If you're looking at doing machine learning and artificial intelligence type stuff, you should probably check out IBM Watson. There are loads of great tools. You can do TensorFlow and lots of other things with IBM Watson for artificial intelligence and machine learning. What we're going to talk about in this session is not so much that, but more around Tensorflow.js. So we're going to cover some machine learning basics. I know a lot of people already raised their hands that they do machine learning, but as the description said, we're going to do a brief introduction to machine learning and then look at Tensorflow.js specifically and do some demos as well. Okay? All right. So let's start off with just some basic machine learning stuff. And again, I know several people in this audience have already done some machine learning, but for those who haven't, we'll cover this quickly. So machine learning, making computers work like the brain, right? That's what it's supposed to be like, or that's what the basic premise is. And it's easy, right? Right? Maybe? I don't know. I don't see anybody saying yes or no so far, but it's definitely a little bit more complex than writing a standard CRUD application. So, and unfortunately, it's not like I know Kung Fu from Matrix, where you just plug in and you do some courses and you learn machine learning. It's actually quite an extensive field, and there's a lot to learn, especially around the math and algorithms and stuff. But broadly speaking, artificial intelligence is the broad concept of machines being able to carry out tasks in a way that we would consider smart. So this is not as much algorithmic, but more about mimicking the animal or the human brain in terms of building applications which can learn and adapt without developer intervention. And machine learning is an application of AI, so it's a subset of artificial intelligence where we should be able to give machines access to data and let them learn for themselves. Right? So pretty basic stuff. Now, when we think about machine learning, we want to aim for software with the ability to learn with data without being explicitly programmed. So what we do today as developers is we go and we build applications, and we basically use our brain to figure out what all the algorithms are supposed to be for whatever business problem we're trying to solve. The key difference between how we build stuff today as developers and machine learning is that we program the computer to learn on its own and to be able to solve those same problems without our intervention. So what can machine learning do? You probably have seen all these before. Email filtering, OCR, language translation, among other things, right? So there's lots of broad applications and specific applications for machine learning. And we'll look at one specific thing in a demo with predictive analysis, right? So we'll use the IMDB reviews TensorFlow dataset to do prediction on when people enter words into a movie review, what star rating will they give it, right? So, but we'll get to that demo shortly. And of course, machine learning is good for doing pattern matching, and everyone likes those cool demos where they teach machine learning to play video game like Galaga or whatever, right? So these are all the different things that machine learning can do, and you're probably familiar, or probably have seen these use cases already. But what is it that we do when we program stuff today? We essentially do data collection and normalization, right, depending on what specific domain you're working in. And then we typically write applications that do visualizations into data, right? We discover insights into that data. And again, this is stuff that we program, and we use our own brains, and we apply certain algorithms to be able to tease out the things that we're interested in the data, right? To get some kind of insight into the data that we have, that we've collected through our applications, or maybe we bought a data set or something like that, right? So this is how we do programs today as developers, right? With machine learning, the basic premise is that we do the data collection and normalization, because that still has to be done by a human at this point. But the machine figures out the other two parts that we would normally do as a developer. right? So we do data collection and normalization. We set up some kind of machine learning system, right? We might use TensorFlow, we might use something else. And then the visualizations, i.e. the insights into the data, the machine figures out on its own. And then the algorithms also kind of come out of whatever we've developed, right? We may use some algorithms to collect and normalize the data. And of course, we'll pick some specific algorithms as we're building our machine learning implementation. But the basic premise is that the insight discovery is done by the machine itself. All right, so one of the nice things as developers, at least, is that we still need humans to do all this. So there's been some noise recently about people saying that, well, eventually machines will be able to just write programs for us, and we won't need developers anymore. But I think we're probably a long way off from something like that. But even when we talk about machine learning, we still have to have humans who do the data collection, cleaning, normalization, and other things like that. And in fact, if you talk to people who work full-time as data scientists or work full-time as ML developers, you will find that most people will say that they spend about 90% of their time doing these three things. Again, these are data scientists and people who work full-time on machine learning. They spend 90% of their time doing this, and about 10% of their time actually doing the cool and fun stuff, which is setting up a neural network and using different algorithms to get the data and setting weights and other things like that. So we still need humans to be able to do these things, and who knows how long it'll be before the machine itself can do it, right? So there are two general classes of machine learning types of applications. The first is called supervised learning. And some examples of supervised learning is classification, is an email spam, or regression. What is the housing market going to do in Boston over the next 5 years? Okay? So these are what we call supervised types of machine learning applications. And what does supervised actually mean? It's like learning with the teacher. The machine learning system that we set up uses training data, and we correct that training data, but we have the answers. And once we reach a specific point, we say, okay, this model is good enough, it has 90% accuracy or whatever, and we kind of stop at some point and say, this is good enough in terms of the accuracy we wish to have for this type of machine learning system. But the key point here is that supervised learning, we have the answers. So we have data that we input into the system, we run it through our machine learning application, our machine learning setup, and we know what the answers are, so we can tune and correct and adjust the system along the way to get to the level of accuracy that we want to get from this specific machine learning app we're building. Right? So again, it's like learning with the teacher. Teacher will correct you and let you know that you've done something wrong, and you, as a human, adjust in terms of that. But with machine learning, as a developer, what we do is because we have the answers, we then go and adjust certain things in the machine learning algorithms and setup that we have to arrive at those correct answers, which we already know what the correct answers are. And this is why it's called supervised learning, because we know what the endpoint is, and we know what the starting point is, i.e. the data, and we basically help create a path from one end to the other. So the other broad category in terms of machine learning applications is unsupervised learning. And a couple of examples of this are clustering, which is, for example, grouping users by behavior, and association. So this could be something like people who buy this thing also buy this other thing. Okay? So unsupervised learning, two broad categories within it, clustering and association. And with unsupervised learning, as you can probably guess, we only have input data. We don't necessarily know what the correct answer is up front. Right? We can usually extrapolate what it is, but it's not something that we feed into our system or into our application to get the machine from point A to point B in terms of what we're doing. Right? And again, the two broad categories that we use, or the two basic types of machine learning systems we build with unsupervised learning is clustering and association. And again, we only have input data. The answers are not necessarily known. And the general premise is that the unsupervised machine learning system it observes and finds structure in data for us so that we don't have to do it in our own brain, right? So this is the general idea around this. So we have unsupervised learning, supervised learning, and let's take a quick look at what we can do with supervised learning to give you a better feel for what some of the typical applications are. So I'm not going to read all of this, but you guys have probably seen these before. So the first one is we input a picture, and the question is, are there human faces? Something like that can be used for photo tagging. And if we jump down to English sentence, we have English sentence. We want that to be in French, and that is a basic language translation thing. So when you use Google Translate, for example, or IBM Watson natural language processing, they both use machine learning to do that translation nowadays. Okay, and as you can see, so there's some other examples of supervised machine learning on this slide as well. All right, so what's an example of unsupervised learning? So in this case, what we're going to do is we're going to feed the machine or the model a set of different pictures of different types of fruit. Right? So we take those, we feed them into the system, and the system self-organizes those images and says, this thing is probably an apple, this thing is probably a pear, et cetera, et cetera. But this is unsupervised learning because we just feed it in data, and the neural network organizes itself so that we get some kind of clustering in this case, right? So the specific problem that we're solving is, I want to know what kind of, or I want to know what different types of fruit there are here in these images, and the unsupervised learning does that clustering for us, and then we can take that trained model and say, what is this thing? And it'll say, it's an apple, right? So we train it, it clusters it into the different groups, and we use this to essentially do clustering types of unsupervised learning. All right, so that is a very, very quick fly-through of machine learning, and we'll dig into this a little bit for a few minutes. And so how do we do all this fun stuff? Magic, of course. You find a data scientist and you say, go fix this for me, or go do this specific thing, and you let them do it. And the reason why, this is not to belittle what data scientists or machine learning engineers do, but the idea is that as a developer, you can do everything. Right? You can be a mobile developer, app developer, and you can build websites, and you can also learn, you can also do machine learning and learn all those things. But typically what we do in software development is we specialize, at least for periods of time, where we just do like back-end server-side development, or maybe we do event-sourced Java applications or whatever. So at some point, probably want somebody else to do these things, and you just want to consume whatever they produce. And that's what this session is about. We let somebody look at the algorithms, figure out all the neural network stuff, right? This person understands how to set weights in TensorFlow and other things like that. And they come up with the machine learning system, and then we, as an app developer, go and consume the model that they produced in our application, whether it's a server-side, or in this case, or in our case here, we're going to go and actually build out a application that uses a pre-trained machine learning model, right? And if you're not already familiar with how TensorFlow and other machine learning-based systems work, they use what are called neural networks. Neural networks are an approximation of how human brain cells work, essentially. And we have different types of neural networks that folks use. A simple neural network has an input layer, and will have a single hidden layer inside of it where our weights and algorithms and other things get applied to produce what we would get in the output layer. Right? And then when we talk about deep learning neural networks, there will be multiple layers of neurons in between to get more precise predictive analysis or calculations or whatever it is that you're trying to do in your application. Right? And if we look at some of the math around this, or how some of the implementation actually works, is there are a number of different mathematical algorithms that we use to model these neurons, right? I've used the word weights before. So yes, there are weights that get assigned, and we assign those weights and weights that are also calculated as data moves through the neural network, right? And you can see there's a few things on here in terms of how different parts of the neural network are used for math, and then there are different types of neural networks, as we saw here. This is just a very straightforward one, but there's also feedback neural networks where data actually can flow in the reverse direction in between the layers, et cetera, right? So there's quite a bit of stuff here, and we're not going to cover all of that here, right? Again, this is just a very brief introduction to give you an idea of what this looks like. So along with the neural network part, as machine learning developers, the other things that we have to do is we have to understand and know of all the different algorithms that we can apply as part of our machine learning application. You can see there's a whole bunch of them on here. These algorithms are in a specific toolkit called scikit-learn, which is based, it's a Python library that you can use to build machine learning applications, or just use these algorithms as you wish. But you can see there's a whole bunch of them. A lot of machine learning systems use Bayesian type of algorithms to get initial data sets up and running. But you can see there's a whole ton of them in terms of how do we go and pick what we want to do. And this is why data scientists and machine learning people are very good at what they do. They understand all these different algorithms, and they know what to apply in which scenarios, and then they run some tests to get some idea of what is a good fit for different types of problems, and they know which algorithms work well for certain types of solutions that they're trying to build, right? But as you can see, there's a whole bunch of these here. And as an app developer, I don't really want to get into all this. What I want to do is I want somebody to go and do all this work that I can't do because I'm busy building an application. Maybe I'm writing a mobile app, back-end services, whatever it may be. I do my specific job. I have somebody else provide me with the data model, the pre-trained model that does what we're trying to do in our business solution. Okay, so short answer is you don't have to be an AI or machine learning expert to be able to consume what is produced by the people in your organization who are data scientists or machine learning engineers, right? All right, so in a lot of ways, we're already using machine learning on a day-to-day basis. So Google Translate is something that uses machine learning currently. And if you also use Google for ASR, or automated speech recognition, that nowadays actually also uses machine learning. Okay, so like if you have an Android phone and you talk into it, and basically it recognizes your voice, and then it does a voice-to-text translation. You are using Google voice recognition, which is actually based on machine learning. And there's an interesting story around this, actually, because for many years, doing voice recognition was very difficult for app developers because of cost. There are a large set of algorithms that have been used for years to be able to do automated speech recognition. And of course, all these algorithms had patents around them. And there's a company called Dragon Dictate, now known as Nuance, that owns all these patents. And unfortunately, what happened, there's an interesting story behind this specific company. At the height of the internet boom in like the late 90s, 99 or 2000, this company had amassed all of the patents required to do very good voice recognition. And the people who owned the company sold it to somebody, I don't remember the exact company, but right after they sold it to this other company, and they did mostly like stock or something, not like straight cash, in the sale of their company, the internet basically bubble burst and everything came crashing down to earth, right? I'm sure there are a lot of people in this room who were developers at that time, and it was a lot of fun seeing everything kind of just crash away. But getting back to our story, what happened was this company had sold all the patents to this, basically they sold the company, including all the patents to this other company. This other company went nosedived and completely was gone, right? So they sold everything. They got virtually no money out of it because most of what they sold their company for was for stock. And then all of a sudden, this company just had like these patents, and basically they were sold again, and then that became Nuance, et cetera. But the point here is that for years and years, to be able to do ASR or speech recognition, you had to have patents from this company to be able to go do it, so to do ASR in your applications. And it was very expensive until Google came around and started to put together a machine learning system that did not use any of those patents, but it learned on its own how to do voice recognition, and that's what we basically have today with Google Voice Recognition is that they actually use a machine learning system that is not based on any of those patented algorithms to do the same thing, which is a really interesting story. Okay. Anyways, quick aside there, to give you some idea of like what we can do with machine learning and how people what is the intellectual property around machine learning and how do people use it to get around IP issues. But anyways, so what we're going to do in this demo is we're going to download and use a pre-trained machine learning model, TensorFlow model to be specific, and we're going to load this up directly in the browser. We'll look at some code in just a second to see how all this comes together. But before we do that, let's talk about Tensorflow.js for a minute. So this library used to be called deeplearn.js, but it's now Tensorflow.js. And if you're not already familiar with what TensorFlow is Google's machine learning platform. And what they do is they model those neurons and in terms of something called tensors, which are data structures and neurons weaved into one. Okay, so we're not going to go too deep into this. I just wanted to give you an idea of what TensorFlow itself is. So TensorFlow is typically something that we code up and write using Python. So we talked about scikit-learn a few minutes ago. Scikit-learn is a Python library that you use in combination with TensorFlow to have the algorithms and other things we typically use when we build out a machine learning system. But TensorFlow is Google's machine learning platform. It's also available on other things besides just Google Cloud. And you can actually just run TensorFlow directly on your laptop, for example. And TensorFlow.js is TensorFlow for the browser, formerly known as DeepLearn.js. Now, it is not as featureful as the standard TensorFlow Python library is. It has a subset of the features, but you can do basic training, and obviously you can also consume pre-trained TensorFlow models that have been trained in TensorFlow Python directly inside of JavaScript. Okay? So you can also run TensorFlow.js outside of the browser in Node if you want to, right? So in the demo we're going to load up TensorFlow.js in the browser, but you can also run TensorFlow.js using Node if you want to. Okay, there are a couple of things that you have to do to make it work properly, but it is possible, and there's some people who have some code that show you how to do that. And before we dive into the demo, let's talk about why machine learning in the browser for a few minutes. And this is somewhat of a joke. There's something in the JavaScript community called Atwood's Law. Has anyone heard of this law before? Right, a couple of folks. Any application that can be written in JavaScript will eventually be written in JavaScript. And this is obviously just a joke because there are some real world use cases for doing ML in the browser. But one of the things is that there's no server round trip. If you can just load a machine learning model directly in the browser, you don't have to go to the server to go say, hey, here's some data, go run this predictive analysis and then send me back the results. And the other thing is we can also offload the work into the browser. So most people on their desktop have a pretty hefty machine nowadays, so we can actually run these models directly in the browser and not have to run them on the server and pay for extra compute time. Okay? There are some limitations in terms of how big of a model that you can load in the browser, but typically most models aren't huge. Right? We'll look at a specific model in just a second to give you an idea of what we're loading up. All right? So let's do a quick demo here, and we'll go look at the code and get off the slideware for a few minutes. Okay? So this is our demo. Okay, it's big enough. All right, so let's make this a little bigger, actually. Okay, there we go. All right, so I've already loaded a trained model here, and we'll look at the code for this in just a second. Let's try loading this up again. All right, so I have a button here, and again, we'll go through the code in just a second. This will take a minute to load up or a couple of seconds to load up our Internet Movie Database, IMDB, predictive analysis, TensorFlow model. Okay, and now what we're going to do is we're going to pretend like we're writing a movie review, right? So what's the movie that they're showing tonight? First Man, is that right? Yeah, okay. Has anyone seen it? Is it any good? What did you think of the movie?
Yeah, it was awesome. Yeah.
Okay, it was awesome. Okay, so there you go. All right, so what we have here is, again, the idea behind this model is that as you put words, write a movie review, it will predict what star rating you will give that specific movie. So gentleman in the front said, it was awesome. So I put, it was awesome. And the score here, it's on a scale of 0 to 1, but a 1.0 basically means 10 out of 10 stars, okay? And you can see additionally underneath it, how long did it take to compute, or how long did it take the model to go and take those words and give us the predictive analysis for what star rating would somebody give it. Okay, so let's do a couple more here. I thought the movie was okay. All right, so wow, that takes us all the way back down to 0, even with the misspelling. Okay, I went to see this movie with a friend, and we both liked the movie. Okay, so that gives us a 0.99. Let's see if we can try to get something in between. I tried it. This movie was okay, and that kind of goes all the way to 0, but this probably should be like a 5 or something, right? So that's one thing I should put a big asterisk next to the rest of this presentation. This specific model is actually not that good, okay? So in terms of like the way that it does predictive analysis, it's very brittle and it's very fragile. It doesn't work that great, but it works okay. All right, so let's try something else. Actually, let's do this. I have IMDB open right here. So let's find something that is like 5 stars. Here we go. So this says it's, this person rated it 5 out of 10. So I'm not going to copy all that. All right, let's try something a little bit better. Okay, so this was 3 out of 10. Let's go put this into our application. And that did not work at all. Okay, this is going to be fun. Right, and one of the reasons I like using this model is to give people an idea of that creating these machine learning models is actually extremely difficult, right? Everyone says, oh, it's easy to learn machine learning, right? It is easy to learn it. It's very difficult to master and come up with a really, really good predictive analysis or whatever you're doing. Really, really good set. It's very difficult to actually get it right, is what I'm trying to get at, okay? So this one got a 0.85 in our predictive analysis, and the user gave it a 2 out of 10. So I'm not going to bother with this one. I think this will probably be a 0, but let's try it. All right, let's see what it says. Okay, yep, so we get a 0 on that. At least that one was good. Let's load up a few more and try a few more out. Okay, here we go. Okay, so that gave it a 0 even though it was a 5. So you can see that this specific model tends to overcompensate for, like, so if I say, oh, this movie was okay, oh, you liked it, so it gives it a 9 out of 10 instead of 5 out of 10. And if you say, I thought this movie just meh, it goes all the way to 0 or whatever, right? So it's kind of, it kind of goes to one extreme or the other, and the predictive analysis in the middle is not very good. And what this, if you're a AI or machine learning developer, what this would indicate to you is that the fitting around this model is not good. So there's this thing that we call fitting, where we say when we're going and trying to get our specific, how confident are we that this is giving us a good result? There's this concept called fitting and overfitting in the machine learning space. So what's happened in this case is that this model has been trained but is overfit. So it tends to go towards the more towards the extreme, and it doesn't have a good fit around the actual results that we anticipate for getting. Right? So that's something called overfitting, and that's what's happening here. Let's just try 1 or 2 more of these really quickly. Okay, so this one gives a 2, right? But the person gave it a 5 out of 10. Okay. Right, and this one also gets a 0. All right, I'm not going to do any more of these, but what I am going to do is try a couple of more here. So let's say I thought this movie was rubbish. Okay, so that goes down to 0. Okay, but so this is another place where this model falls short. You see what I did is instead of using the word rubbish, I just misspelled it. Okay, so it doesn't accommodate for spelling and grammatical mistakes, right? So that's something that we would maybe clean up before we threw into this specific model to get a result out of it. But you can see if I go back and spell this properly, it goes from being good to like basically 0, right? So these are things that as an ML developer we would want to go in and try to fix, or at least have the input data be scrubbed in some way so that it fits the model better. Or what we would do, hopefully, is have a model that can accommodate for these kinds of small spelling mistakes or grammatical issues or other things like that. Okay? All right, so let's actually go have a look and see how this is put together. Now, this application has been written using React, but it doesn't matter. You can use no framework. You can consume and use TensorFlow models in JavaScript using Angular or React or Vue.js or whatever. Okay, but this application I just decided to whip together using just straight React. All right, so let's go to the important or the interesting parts of this. All right, so here's our React application. Actually, let me make this a little bit bigger. Or move this over a bit so we can see both of them on here. All right, so we have a page header, text sentiment analysis. We have a button here. This button is what we use to load the model, right? And we set it to disabled once the model is loaded because we don't need to reload the model once it's on there. We just need to load the model once and we're all set. And then we have a panel with our text input. And then what we say is, actually, let's start from the beginning. Let's go and see how we load this model. So we have a handle click here. This handle click goes and fires up this tf.init model. So what I did is with the basic TensorFlow library, I just created a little service library. Right? And so the specific thing we were hitting here is, where's our model? Right, TensorFlow.init models. Our TensorFlow is this TensorFlow loader service library, if you will. And the way that we load this, there are a couple of different ways we can load this. We can load this over the internet directly from where it's stored here. Right? So what this is a standard TensorFlow Python model that has been run through a converter to convert it for consumption for use in TensorFlow.js. So you can't just take like a raw, like kind of binary or whatever TensorFlow trained model. You have to do a conversion step so that it can be used in TensorFlow.js. And essentially all it's doing is it's just converting it from that kind of more binary format to a standard JSON format that can be sent over the wire and read a little bit easier by a JavaScript runtime. Okay? And actually we can go look at that model right here, right? So we're loading two parts. We have the model itself and the metadata around the model. So let's go load up the model really quickly. And in this specific model, you can see these are the configurations for the tensors, right? So we have a couple of different ones here, and then more tensor configuration, et cetera, right? And you can see that some of these have values assigned to them for how it is specifically going and searching. Here are the weights for all the different tensors. So I mentioned weights earlier before, pads, etc. And then the metadata itself has essentially indexed numbers for all the different words that were input into training this model from, again, from the IMDB reviews data set. Okay? So this is a huge file, so I'm not going to try to scroll through it. But these are basically weights assigned to numbers and IDs so that the model itself can go in and load all those things up. And let's actually have a look to see how big that specific model is. Right, so let's pull up the public folder and, well, let's do this. Oops, there we go. So you can see that our model is actually very small. It's only 8K in size, but it's the metadata that is also associated with the model, which is about 2 megabytes in size, right? So our total model, including the metadata, is about 2 meg in size, and that's what we're loading up into the browser, right? But let's go see how we actually load that up. Okay, so here's a library. Our entry point was init models, so I'm going to say go and load the model. Okay, so we do TensorFlow.load model, and now this TF is referring to the actual, this TF variable is actually pointing to the TensorFlow.js library. Okay, so we go to the library and we say go and load this model with the URL, and once this starts coming in, these other functions get fired where we go and load the metadata, and this is where it goes and loads the metadata along with the model itself, right? So that's fired from a bit further up. Right, so we load the metadata, that goes and gets our stuff loaded, and this is the part we're interested in. How do we actually use that loaded model now? All right. So first thing we do is we take all of the words that are in the input, all the words which are in the input text area right here, and we put them into a data structure which we will be feeding in to our TensorFlow model. So we say, go and create an input buffer that has all the words inside of it, and because we want this performance analysis for how long did it take to actually run some data through the model and do some predictive analysis, we're going to say, go and start a performance metric, model.predict with the input, and then we go and get rid of that specific prediction once we have the numbers out of it, right? So we'll get the score out of it, predict out, right? So again, here's our model. We told it to go and do a prediction with this input. From the prediction output, go and get what the score was. We go and dispose of that instance of Tensorflow.js running, and then we just return the score and how long it took to actually do that prediction. And it's as simple as it gets here. Right? There's not much else we really need to do to be able to use a TensorFlow model in the browser here. Okay? So we have this. Let's go back to our application.js. And this is where we initialize the model. And then when we hit this button, when we go and put words into our text area, so here's our text area where we've been inputting stuff, right? We say on change this.get prediction score. And if we go to this.prediction score, you can see what we're doing is we're saying TensorFlow.predict, which is this function we were just looking at a second ago. So we load the model up first. Then once we have it loaded, we say, okay, go and take all the words and feed them into our TensorFlow model. Let's see how long it takes by starting this little performance metric thing that runs around it. And we let the model go and be exercised. And again, that part of the code is inside of the TensorFlow.js library that we've loaded from here. Okay? And so the final thing is that once that result comes back, we use React's this.setState to go and set the state to go and show those specific values, and that part is relatively straightforward. Right? So we say this state score, right? If you remember from what we returned from our predictive analysis here, we return a score and we return an elapsed. So we say this.state.score, go show that up to 3 decimal points and show how long it took to run it, right? And I also put in this progress bar for a little bit of extra screen widgetry here. All right. So that's TensorFlow.js, and we have some models. Let's make sure we've covered everything quickly. Okay. So in this case, what we've done is we've done predictive analysis, but specifically sentiment analysis. So we're using this pre-trained IMDB reviews TensorFlow model to identify and categorize opinions and trying to figure out if they're positive, negative, or neutral. Okay? And we kind of got okay with it, right? Again, it's not a great model and it doesn't accommodate for different things. The basic idea behind this is when they train the IMDB reviews model, a 7 to 10 is positive and a 1 to 4 is negative, and then something in the middle is, you know, whatever, right? Neutral. And again, the way we use this is we have dataset, magic, we get the trained model, that's what we import into the browser. Right? And this specific model is what we call a convolutional neural network, so that's what they decided to come up with, or to come up with this specific model. They used a convolutional neural network, which is a variation of a deep learning model. And there were pre-labels in this, so what this means is that this was a supervised machine learning data set, right? Because we know, based on the data that's input, so for example, if we just go here really quickly, right? So we have all the words for the review, and then we know what the quote-unquote answer is, right? So user punches in a review, They give it 4 stars out of 10, so we know what the answer is. So in this case, this is a supervised machine learning data set because we know what the answer is. And what we do is we feed in the data and we do corrections to the algorithms to get as close to possible in terms of accuracy for reaching this final score for the words that are in this, i.e. the sentiment that somebody has when they are doing a movie review, right? Let's try one more of these, actually. I've done one before where I've actually gotten a 5, and of course it doesn't work, so that's okay, right? Again, there's some shortcomings in this specific model, so ridiculously bad and unbelievable. I'm sure that would rate very low as well. This was a 3 out of 10. So yeah, so now we're going to 0. So you can see it's a little bit overfit, and it tries to go to the extremes when we put together a model. Anyways, so the IMDB reviews model is a CNN, supervised learning, and when we say label here, that means we know what the answers are, or pre-labels, okay? And we've already done this, so we'll skip over this part, right? And again, what we did is we load the model in a very specific way, right? There's actually only one way to load it. We did predictive analysis, and then we showed the results, right? We did the code walkthrough. I don't think there's anything else we really want to do. But in terms of what are other things we can do with Tensorflow.js, in this case, we use the existing model. But one thing we could actually do with Tensorflow.js is we can actually retrain or augment an existing model that we've already loaded. So we could theoretically run something in the browser that would train this model further. So we can also create a brand new model with Tensorflow.js if we want, right? So that's the third bullet where we can actually define a model. So with Tensorflow.js, it is not as completely featureful as TensorFlow Python, but you can do the basics, which is consuming and using models and also training brand new models or retraining existing models that we have. And some of the demos that you'll see for this are actually around also for example, I don't think it will pull up with the conference Wi-Fi here, but there's some demos that you can look at the TensorFlow.js website where you can flip on the user's camera in the browser and say, hold up an apple. And then they hold up an apple, it takes a picture, and it basically can train that model directly in the browser. Okay? So one of the things we can do with this is we can broadcast this out and have people just train parts of the model, and then we can actually collect those different trained models from different people and merge them together into a single model if we wanted to. I don't know if you can do the merging part directly in TensorFlow.js, but you can definitely do it with standard TensorFlow and Python, right? So again, a number of different use cases. You can use the camera to go and do training of a model. You can also use a camera to say, hold something up, and you can use an image recognizer. So there are a bunch of other TensorFlow models that you can get that you can also load into the browser, and one of those is image categorization. So you can say, hold something up, and it will tell you that, oh, this is a fruit, or this is a car, or something like that, right? And again, all this can be done directly in the browser without having to round trip to the server. All right, so we have a few minutes left. We can take some questions, or maybe just leave for the keynote or whatever. Any questions, comments? Does that make sense? Yes, sir.
With the model, if the model in the browser is augmented, so we still have the possibility from TensorFlow.js to extract this model and to push it elsewhere so that we can work on it in TensorFlow afterwards.
Yeah. So the comment is, if we go and train the model more in the browser, can we take that data for that model and then go back to Python or TensorFlow in Python and basically merge it with another model or use that extra data that's been collected? And the answer is yes, you can do that. So you can take a TensorFlow Python model, convert it to TensorFlow.js, and also go back in the opposite direction. So yes, you can do both of those. And there are specific things in the TensorFlow library that allow you to go and manipulate the model. All right, let's just have a quick look since we have a little bit of time to do this. All right, so you can see retrain existing models, and of course they have a video game here. But let's see if let's just jump to the API reference real quick, right? But if we look at the API reference, you can see that it has most of what you would get in TensorFlow Python, right? So you can go and directly define a tensor, and this is massive API doc, but yes, you can go and take those models and pull them out of the browser and send them back to the server if you want as well. So that is possible to do that. So what you can do is you can actually do distributed TensorFlow training directly in a user's web browser if you like. Okay? More questions, comments? Yes.
Are there websites that compare how good different models are? You can, well, build apps, or when we build websites, we can choose between many different models to do the same, or many different algorithms. How do you know which is the best and how accurate it is?
Yeah, so that's an excellent question. The question is how do you know, first of all, where can you find pre-trained models? Right, so if you do a Google search, you'll find a few places that have pre-trained models. A few years ago, a lot of people were saying that in the future, you'll be able to just go to a marketplace and buy pre-trained models to do things. Unfortunately, it doesn't feel like that has quite happened yet. But there are places where you can get freely available models that are both small and very large. In terms of knowing how well the model actually works, I think it takes some trial and error. Obviously, it's the internet, so you can find people who've commented on specific models and stuff like that. But unfortunately, there's not like a central resource where you can go and say, hey, I need a model to do, actually, image classification is actually a well-known art. We could have actually used the TensorFlow image classification model or demo data set that they have from Google to do that, and it actually works quite well, but it's also very large. And I don't know if that would actually even load in the browser if we'd run out of memory. I think it would, but I'm not sure. But unfortunately, there is not a single place where you can go and say, these are the models I'm interested in. You kind of have to dig and search and go through different websites. And some models are actually not written according to the TensorFlow basically structure. So you have to sometimes convert those models into TensorFlow and then convert them into Tensorflow.js if you want, right? Because there are a couple of different ways that people build machine learning, and TensorFlow is one of those ways that are done, okay? All right, any more questions, comments? All right, thank you for coming. I hope you enjoyed the session.